You want this back?
Okay, so next session is an overview of the gNMI support in the Stratum. So I want to ask anyone here gNMI here? Okay, like 50%. Okay, so I will give a very quick overview of the gNMI and the open config model we're using in the first few slides. So this is outline. So yeah, open config gNMI, some overview, and I'm going to talk about the gNMI support in Stratum. We call it the config monitoring service. And then we talk about how we use the open config model in the Stratum project. And I have a quick, short video demo. And then talk about how to contribute this part in the Stratum. So feel free to ask me a question if you have a question. So first is gNMI. So gNMI is a generic API to read and write the configuration or state of your device. It's suitable for any tree-based data model, so it's not binding to any model. But Stratum uses OpenConfig and a set of OpenConfig model. So you can use any models. You can define your own models for devices if you use a gNMI. So gNMI provides very simple for RPC code capabilities, get, set, and subscribe. And how we use the models in the gNMI. So first you get, for example, YAML model or other model language you define. You can get things like OpenConfig interface, and there's a container called interfaces. There's a list of interface with key, name, and there's a container in there, config. In the container, maybe there are different things like port enable or port disable or alternate things. Then they convert to gNMI path. Looks like this, like interface, select interface, slash interface, with n equals to 0, config, and so on. It's very easy. So you want to get, set, subscribe, any config leave you want, you can just convert this model to this path and use this path to your gNMI request. And so next thing is an example of the gNMI request. So for instance, we want to get a path, like the interface index of interface is 0. So we'll generate gNMI get like this. We have path, several elements for different these elements. And some element may have a key, like currently we support the key name, like in the key name here. Then you have different elements like state, index, and you can get different types. For example, I want to get the state type, I want to get config type, or if you want to get all types. And you can specific encoding like proto or other things. Then you will get the gNMI response. So the gNMI response will include like notification, the time span, it generates the response, and the updates of the path and the value. For example, the value of this 0 is 1. So it will return the unsigned integer value. The value can be a lot of different types and value. Can be string, boolean, integer, unsigned integer, or a byte string, or other port above. Okay, so this is just a very quick sample example of the gNMI request. So next is about the OpenConfig model. So OpenConfig model is a vendor-neutral data model for configuration and management that are supported by different kind of hardware or software. So it defines very general things like interface, VLAN, QoS, LACP, and so on. And as I mentioned, so Stratum, we only use a subset of the OpenConfig model with some modification. So Stratum do some deviation and augmentation to the model. Like we also put some vendor-specific model to Stratum support. And so before we take a look at the gNMI support or the config monitoring service, we do some recap here. So here is the basic Stratum architecture you can find in our website. So, but this session will only focus on this part. the gNMI and switch interface or switch broker interface. But if you're interested in different part like the port management, the chassis management, platform management, or the table AC management, you can attend next few talks. So first, the config monitoring service. I will give a lot of details. More details in this talk, not just general, and it's maybe a little bit complex. So, so this is the event code here, but I not go through this slide. If you are interested, you can just go to me, ask me. Yeah, I'll break to several parts to explain everything inside. So, okay. So first, we have the gNMI service. We have config monitoring service, which implement the gNMI service interface. If you remember, the gNMI service definition defines 4 RPCs, which is capability, get, set, and subscribe. Then in the config monitoring service, we have several components. For example, the authentication policy checker will check if this gNMI request is valid or not. And we have the gNMI publisher. This is the one important part in the config monitoring service. We'll talk later. And we have yum-repository, which stores actual the gNMI, the model tree in the Stratum system. Then this yum-repository will actually talk to the Stratum broker interface to get the value or do the set value config things. So how to implement this setting, like if you want to enable disable ports, you want to query the counters, that's implemented in the lower level, like switchboard interface. So different platforms may have different ways to implement that. So only focus on the top level here. Okay, yeah, also the config monitoring service also handles the gNMI subscription. For example, if one client or controller have multiple subscriptions to different ports, different paths, then it will match all those subscriptions to check if it's live or into sent event. Okay, back. So the config monitoring also will push the Stratum chassis config, I will talk next slide, to the switch interface and the gNMI publisher to initialize the tree and all the switch interface. Yeah. So here's some example of the chassis config. So the chassis config is an internal, the Stratum data structure to hold all the chassis. Like you have ports, we have nodes, we have VLAN configurations, we have some vendor service configuration. We all stored in this chassis config. And when we start the Stratum, we load this chassis config to a Stratum, and Stratum will do the rest of things. And the chassis here means a switch box. So you have switch box here. And so most of switch is like one switch with one panel port. But some of switch or some of chassis, they may have different nodes, like different slots, like mini-pack switch. So we define the chassis. You can define multiple nodes, which maps to different data plan ASIC. Yeah, and not just like this. These are very simple. We also support things like trunk ports and so on. Okay. And Stratum also allows you to push entire chassis config via the gNMI. And we'll talk later about how we manage push entire chassis config or read entire chassis config from Stratum. Okay, so next part is the gNMI publisher. So the gNMI publisher takes the chassis config from the config monitoring service and to create the tree. So after we create a tree, you stores some state value or you stores some callback functions in the tree. I will show the tree details later. And every gNMI request from the controller will go to the config monitoring service, then go to the gNMI publisher. Also, gNMI helps the configuration to create some we call internal subscription for the gNMI subscribe. And also it process the switch events from the switch broker interface. Then handles the event from the event reader. There's a loop inside there, handles that, and decide what to do, like send the gNMI event to the controller of your client. Okay. And next thing is the tree we stored. So the publisher actually generate this tree based on the chassis config. Like we have one chassis, we have nodes, we have sync ports, we have trunk ports, and vendor config. Then it will take all the configuration to generate different paths. For example, if we have the one single port, then it will generate interfaces paths. For example, enable, disable, auto nag, speed for just that single ports. Okay. And so how we store the config and state in this Stratum, the tree. So actually, we don't store actual value in the tree. Instead, we store a functor or the handler inside the tree. So first, we create this tree, and then we store several handlers in the tree. So one, if you want to query a value from the leaf node, you need to call the port handler. Then port handler will help to get the value. So some handler will just return a value. Some handler will ask this switch interface or switch port interface to query a value. For example, we want to query some counters. Then we won't store actual counter value in the tree node. We will ask the switch interface to return some counter value here. Yeah, so we have a request. We have this event, and we ask port handler to ask the switch interface. Then we reply to the string. For example, you want to use the subscribe port once. You just return to a string. So next is about what I mentioned. So Stratum allows you to push entire chassis config via the gNMI. So we actually push or query the entire chassis config from this root path. But before you push, for example, you want to push the chassis config, you need to convert to the OpenConfig model protobuf message, then push to this root path. And same thing, if you want to get entire config, you will get OpenConfig model defined gNMI byte string from Stratum. And we use the Young to protobuf compiler from the WiGOT repository, WiGOT project, to compile the OpenConfig YAM model, and we combine several models, as I mentioned. So we only use the OpenConfig set of OpenConfig model. We combine OpenConfig model, and there's a Hercules model and the Stratum model. They are all open source. You can find in different in 3 repository. We combine those models and compile to single OpenConfig proto. So what it looks like from Young model to protobuf. So we have a Young model, like OpenConfig interface, and the OpenConfig proto generator. The proto generator will generate looks like things like this. So there will be a high-level message code device, include all the trees of your models, like the interface. And for some list with key, you will actually generate the interface key. And we have to repeat interface key with the actual key and the interface itself. Then we have things like, for example, there's an operation status. It will just map to an immersion with this message inside. Yeah. And I think the last part is I'm going to show a demo with dummy switch with very simple CLI and gNMI. And anyone want to contribute to the gNMI part of Stratum can also use the dummy switch for testing. OK, so let me give a quick view of the dummy switch. So the Stratum dummy switch is actually an implementation of the switch broker interface. So we have dummy switch, we have dummy node to control, we call fake data plan. And we have p-hole interface, dummy p-hole, and we have dummy traces manager. And we have simulate like hardware level called dummy box. And to simulate the events, like you update port counters, you update the port states, we have another RPC interface allows you to generate this event. Then the dummy switch will send actual gNMI event to the northbound, to the Stratum hardware Stratum layer or the gNMI service. So let's see the video here. So first we started dummy switch with, I think it's a bit small. So with there's a chassis config. Here we start. We start dummy switch with the Bazel ROM, and we push some flags for pipeline, chassis config, and listen ports, and some persistent directory. So you can see it listen on 28,000 ports. Then with the gNMI CLI, you can find gNMI CLI in the Stratum repository or in our tutorial, Stratum tutorial. So for example, we want to get the value of interfaces, and then we use a wildcard, and we get the state, and we want to get every interface name from the Stratum. So we can use the CLI get this one. And then we'll get several notification or the gNMI. We'll get one gNMI response with several notification. So this is how we build the gNMI path. And we get, for example, the first interface with the name string value. Actually, the key shows the name. And we also get this name string value. So two interfaces in dummy switch. Okay. Then, okay. So next thing, we want to subscribe a port counter. So usually we use the subscribe sample, but dummy switch supports subscribe on change. So if port counter change, then it will send a gNMI event to the controller or our CLI. So this first part, we get every port, every interface names. And we also use, there is a dummy switch port counter simulator, which will send a port counter update event to a dummy switch lower level box. And dummy switch will generate port counter update event through the gNMI. So gNMI will send the subscribe event to our CLI. So first we subscribe. And when we initialize subscribe, you will get the first value, like 0. You actually do the gNMI get first. You'll get the first value like 0. So you use mode on change. So when you change, you'll get a notification here. So we subscribe the input inbound unit packet, unicast packet, and the initial value is 0. Then we start this port counter here to simulate the node 1, port 1. So it's just random generate, increase the port counters. So you can see these CLIs keep printing new value because it received this subscription notification. And we'll see the input package going to like 83. This simulator, then we see the subscribe events also goes. Yeah?
Is there a coalescing interval for counters, for on-change counters?
You mean for the real platform? Or?
Yeah, like if you're just constantly doing, what is the minimum interval?
Yeah, so there's different mode for subscription. You can also do the sample.
Right.
Yeah, so you can tell the gNMI client, you can tell Stratum to send the value each second or different each few seconds.
Okay, so if it's on change though, the counters it's just constantly going to be.
So on change mode, if there is an update from the lower level, like your ASIC or your low has some configuration state, so it would be nice if I can have new test for the test vector. Also, we have the talk here called test vector framework. Australian will switch 3 p.m. today, tomorrow. And new platform component support. So currently we have 6 vendors, and we have 8 platforms. 8 platforms support. If you want to join, feel free to join to support your platform with the OpenOffice API. And not just platform lower level. Also, we have this manager, the platform manager, tracing manager support. There's an internal DB called PHODB. You guys can stay here to listen next session about the PHODB. Also, new platform, not just the switch. Also, we also want to support the optical transport devices. So if you're interested about this part, maybe you can stay 5 p.m. There's another talk about this. Okay, thank you. If you have any question, you can ask.
I have a question just because I don't know the answer to this. So when you're translating the Yang to protobuf files, is there any kind of loss of fidelity of information at all, or is it basically like a one-to-one match for like you lose the descriptions in proto, right? But and is there anything else that you lose by translating to protobuf? Do you know?
Yeah, so we translate the Yang model to the protobuf. Is for there's an internal open config converter converts when we push the entire chassis config or push entire configuration using protobuf open config format to the Stratum. Stratum need to convert this part to the chassis config for Stratum switch. So this is what we are using.